So now what we have to do is we have to bear in mind, well, once again, keep our perspective here. We're down really to the last layer. Now this is the equivalent of, if say, this was in, then we'll have everything done, this is in, and now we got to put these guys in over here. These guys in, then these edges in, then the last layer. So I'm going to do the equivalent of these corners. And that would be, well, if this is the top layer over here, let's look at all the corners that aren't in, such as this. And most of them are going to be on the top side here. Some of them will be stuck here. So these are those corners that I was talking about. This, this, and this. So let's look for this one first because it might be easiest. Orange, green, and white. Yellow, green, and white rather, which is here. So we just flip that in. This is among the easiest to do. Bang, there it is. This white triangle is free to come into this guy over here. Turn, turn, turn. Now I got to be careful because it's starting to look more and more like a tetrahedron, which is not what this puzzle is. So I can't be fooled by that. Bear in mind, this is still our first layer and our first side. So here this is green and yellow, which is probably here. So let's move that out. And now we move this into here, turn, 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 and we just simply roll it in. Okay? Now what other corners are not in? Well, there's this one, which is red and yellow. I think it's mostly red, so it's this guy. Turn, turn, turn. And I'm just kind of literally picking up the pieces. This is a corner that doesn't belong on the top side here, and it looks like it's a red and white, this guy here. So turn. No, not yet. This should do it. There we go. Okay, so as I'm cleaning things up, I appear to have all the corners in. So this is my last layer here. Everything is in except for the edge. The edge is just before my last layer. So in this one, that's the equivalent to this being the last layer. These edges aren't in. I just put these corners in. Now I've got to put these edges in all the way around and then get to my last layer. So edge, yellow and yellow, which is going to be this guy here. I'm just going to turn it down here to see if it matches, and it does. So now I'm back to the beginning, sort of doing an edge swapping algorithm here, edge placement. This is now my U, R, UI, RI, UI, FI, U, F, and that's in. So I'm going to keep finding edges. Well, this is the right color scheme, but the wrong shape and size. So yellow and red. And let's see, here's another yellow and red here. This is in the wrong place here. So let's pop this out. I need this white. Does it come into here this way? Sure. Or does it? Let me see. Yep, like the other way better. Turn, 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 turn. Turn, 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 and turn. Again, I can't say enough about how smoothly this puzzle moves. So this is no choice but to be here. Don't even have to check it, because it's the last option. Turn, 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 and turn. As you can see, it agrees. Okay, more edges to clean up. Brown and rather red and white. Here's a red and white. Let's see if this matches it, and it does. So this is the easy part. This one doesn't have too many issues with perspective because, you know, I can visualize where the last layer is. Turn, turn, and turn. So far, so good. White and yellow. It could be this, or it could be this, which it is. Turn, turn. This is the part of the Megaminx solve that goes the fastest. And turn. Do I like it? Yeah, sure. I like it enough. Alright, so all this is fine. Now we have just the last layer. So this is your classic smashed last layer look to it. So it's a question of rotating these back up. So how do we rotate this? Well, if I'm going to do this like a 3x3, as you recall, to do these last layers, first thing you have to do is you have to rotate these in the proper position. So you have to orient these. I orient these using the same algorithm as a 3x3, just like orienting these guys, and that's FRU, RIUI, FI. And when I do that, it's going to cause a specific kind of flipping around. If I do FRU, RIUI, FI, you can see what happens here. FRU, RIUI, FI. So what happens is this stayed exactly the same. This didn't change, but this yellow, this orange and green went over here. This shifted over here and it flipped. This shifted over here and didn't flip, and this came over here and flipped. So basically what happens, this stays the same, this one flips, this one shifts, and this one flips. So it comes over to here and flips. So when I have this L formation here and I do it again, this will flip over here, this will flip over here, and this will shift over here. FRU, RIUI, FI, giving me this line. And finally what will happen is this will stay the same, this will shift over here but not flip, so this will still be oriented right, this will flip over here, so it'll be oriented right, and this will flip over here and be oriented right. FRU, RIUI, FI. So the end result is that these things end up getting permuted appropriately. Now with the Megaminx, you get something similar to that, except when I do FRU, RIUI, FI, these two are going to be sort of moving as one. So I have to look at it exactly the same way. These will stay the same. This will flip, this will shift to here, and this will flip over here. So it's the same kind of thing. So if you notice, if I go FRU, RIUI, FI, that's actually what happened. These stay the same. This pink and blue flipped over here. This pink and green flipped over here. This white and green shifted over here but didn't flip, and this light blue and green flipped over here. These two stay the same, so these two is like this one here. So if I do it again, what's going to happen is this will still stay the same. This will flip over here, this will flip over here, and this will shift over here, giving me, instead of a line, it'll give me kind of an arrow. These two stay the same, and this will be flipped right. FRU, RIUI, FI. So indeed, that's what happens. And now upon doing that, if I do it again, these will stay the same, if you notice. And this will shift over here and be where it needs to be. This will flip and shift, so this will be oriented correctly, and this will flip over here. FRU, RIUI, FI. So everything is fine over there. So now I have to translate that into this. So which is right side up and which is upside down? Well, that's a little complicated because we have to be careful about certain parities or certain things that will not happen. If I'm going to say these two are right side up, that's an impossibility because that's just one that's right side up. That would be the equivalent of just this being right side up and the rest upside down. You can't really have that. You can't have one that's flipped. So I can't say that that's the case. And I can't say that just this is right side up and this is upside down. So here's what we know. These are all upside down. They have no choice but to be upside down. Which means I gotta say that these are upside down too. I have no choice, because if these three are upside down, I can't have one of these at right side up, and I can't have two of these right side up. None of those configurations would make any sense. So what I'm gonna do is I'm just gonna do a random FRU, RIUI, FI and see what happens with that. These two are gonna stay the same, but I'm gonna get some nice flipping of these guys. FRU, RIUI, FI. So what do we got? Well, this is right side up, this is right side up. So if these two are right side up, I'm going to say this must be right side up, this one over here. It's the only way that that's going to make sense, because that gives me a little arrowhead over here. So these must be right side up. And this is upside down and this is upside down. So if I do it one more time, then these two, then everything should be right side up, because this is, like I say, equivalent to the arrowhead. So FRU, RIUI, FI. So yeah, everything looks to be right side up, and it seems that all is right with the world. Now all I need to do is I need to orient these guys around. Well, I'm going to move this over here. I've got this one that's in. In terms of permuting rather, in terms of permuting these guys, with this in, I have to put all the rest in where they're supposed to be. This obviously doesn't belong here because it doesn't make sense here, and this doesn't make sense over here. So what kind of algorithm am I going to use? Well, it's going to be a variation of the 3 by 3. if I look at these happen to all be in. These happen to all be correct. But if I wanted to permute these around, I go R, U, Ri, U, R, 2U, Ri. This stays exactly the same. This yellow one went here, this blue one went here, and this white one went here. So this permutes these around doing a counterclockwise rotation. And if I keep doing that, eventually these are going to come back in. R, U, Ri, U, R, 2U, Ri. One more, and this orange and white, orange and yellow will be right over here, and these will all be around fine. R, U, R, U, R, 2U, Ri. And all is right with the world. If I do this Megaminx style, right now all of these are in, but notice what happens if I do the same thing. Now instead of RU, RU, R2U, Ri, I've got to do 3U, Ri because this is 5 sides. So I won't, if I just do 2U at the end, it won't all come back. So it's going to be RU, Ri, U, R, 1, 2, 3U to get this in, Ri. So here's what happened. This stayed the same, so did this. These two are like, they're connected. This white one went here, this blue one went here, and this black one went here. Exactly the same thing. So if I do it enough times, I'm going to eventually get them all back. So I put one that's in front of me, the other just to the left, and do R, U, Ri, U, R, 3U, there it is, Ri, and one more should do it, R, U, Ri, U, R. So when translating cubes to dodecahedrons, I do the same algorithms, I just bear in mind the different sides. So I'm going to do the same thing here. Now, what have we got? Well, I've got this one that's in, and I need to put one next to it. I know this will stay the same and this will stay the same. But what I want to do is I want to put one of these guys in over here, in the proper place here. Does this go here or does this go here? Well, it's kind of hard to say. So what I can do instead is just kind of reason this out. This one belongs over here. Why do I know that? Because this, since it's right side up, doesn't belong here. If it doesn't belong here, the only other place it belongs is here. So if I hold this over here, this will stay the same, this will stay the same, and this will end up over here. And I know that this doesn't belong here because this doesn't belong here. So therefore this has to be here, if that made any sense. So this belongs here simply because it doesn't belong here, which means this must belong here. It's the only other option. So I'm going to do that same algorithm until this ends up here, and then I'll have two in that are next to each other. R, U, Ri, U, R, 3U, 1, 2, 3, Ri. And not yet. So now this is the same. This is now going to plop over here, and we'll see if our mad theory works. R, U, Ri, U, R, 3U, 1, 2, 3, Ri. And there it is. So now that I have these guys in, I can now move this one in front of me, knowing this won't change and this won't change, and move these all around until everything is where they need to be. One more mighty turn of that should put this here, and this here, which is where they need to be. R, U, Ri, U, R, 1, 2, 3U, Ri, and there it is. So you can see all of our edges are in. Now corners. So the way corners are done is it's going to be a variation of what happens with cubes, and what this is going to do is this is going to keep this exactly where it is, and these guys are all going to rotate. So what I have to do is I have to look to see, is there any one that's already in? And these edges are already calibrated, and I find that no. So I'm going to leave this here, and I'm going to put this so that this is just to the right. This will stay where it is. The rest are going to permute around. So we'll do UR, UI, LI, URI, UIL. This stays the same, but that's okay. What I did is I put this one in. So now this is going to be exactly where it is. These guys are going to all permute around. UR, UI, LI, URI, UIL. This is in, these two are going to be in as well. So now these are all oriented correctly. Rotate this around, RIDIRD, RIDIRD. Bring this one in, and the same thing, just keep doing RIDIRDs into submission until it's in, and that's how I do it with the cubes. Now, how does this translate to the Megaminx? Well, it's the same kind of thing. But instead of doing U's, I've got to do 2U's. And not just any 2U's, I have to identify which 2U, to the right or to the left. But what this is going to do is this is going to hold not just this constant, but this constant as well. So is there any one that's already in? And if the answer is no, I'm just going to randomly hold one here and just do the algorithm. It's going to be 2ur 2ui li 2uri 2ui l. So I actually have to do a 2u clockwise or counterclockwise. So this is where it needs to be. Now, is there anything that's actually in? And the answer is not yet. Now these two are still going to stay the same. Let's do it again and see what happens. 2ur 2ui li 2uri 2ui l. And we see that this one is in. So if this one is in, now I want to move this over to here because this is going to be protected, and I want to move something into here or into here. And which one is that going to be? Well, it could be any one of these two. So I'm going to do the algorithm again, and I'm going to do it until this one ends up here. This one is going to be fixed, but we don't really care about that. I want two that are fixed next to each other. 2ur 2ui li 2uri 2ui l. You're basically getting the same pattern, but doing it to this specific form. Do it again so that this can come into here. 2ur 2ui li 2uri 2ui l. Okay, that's what I wanted. So these two are in. I'm going to hold this over here. These two are going to be held constant. These guys cannot be in, and they're not in. Do it again until they're rotated correctly. 2ur 2ui li 2uri 2ui l. And now you can see that they're all in where they're supposed to be. I just have to RD them into submission, so to speak. So this is all rolled in. So I'm going to hold this over here and just roll this in using RD moves. RD. Keep doing that until this one is in RD. Don't forget that D, and this is defined as D. Move this around and do the same thing until it's in, and you will find it magically solved. So that's okay. I showed you how I don't do this, much different than this. This is the same thing. So which one of these are in and which one of these aren't in? Well, this is in. This is not, but this is. What I really want to do is I want to take this and move it to here. So if I do that algorithm, this will remain constant, as will this. I don't really want that. I want to move this out. So I'm going to move it here so that I can hold these two constant and move this one out so I can eventually move it in here. So same thing. 2ur 2ui li 2uri 2ui l. Okay, the reason why I did that is just to move this out of here. So now I'm going to hold this here to hold these two constant until this finds its way into here. 2ur 2ui li 2uri 2ui l. Once more. 2u. Let's not get confused here. 2ur 2ui li 2uri 2ui l. Okay, so we're good. These two are in, and these two just need to be switched around. So if I hold it here, these two will remain constant, and these guys will all flip around to where they're supposed to be. 2uri 2ui l 2uri 2ui l. Do you like it? Not quite yet. One more. 2ur 2ui li 2uri 2ui l. Now I like it. All these are in. We just have to flip these around as well. So we will do it. So here we go. RD, RD. This is in. Move this over here. RD, and uh-oh, we have a problem. We fixed the last layer, but this isn't fixed. Something went wrong. How could this have happened? Well, the reason why this happened is because not all of these are rotated correctly. This is, and this is. But what would have really thrown you off is the fact that we have a fallacy of false equivocation. We're falsely equivocating this piece. Remember how I said that this could be rotated any which way? Well, the problem is it can't for the solution. This remains to be rotated wrong. This remains out until I rotate this around. This is exactly the same kind of problem we ran into with the Megaminx series, where because this can rotate any way, you won't know if it's rotated correctly or not correctly. Exactly the same problem with this when you saw that one of these was rotated out, but the rest weren't. So basically what that means is I've got to do this again and keep rotating this around until this is put in correctly. And that's the difference with this. That's what you don't get with the Megaminx. That's what you don't get with the RLMinx. You get this basically just with this puzzle, and that's the layer of complexity that's added onto this. You get something from this that you get not with this, but with this guy over here. You get the same kind of potential parity when you have to rotate something around. In this case, the rotation is this. So this over here, this triangle here has to be rotated around and around until eventually everything in the last layer is actually completely correct. Otherwise, the rest of the puzzle won't make any sense. The rest of the puzzle will appear to be out. And you'll even have a situation where one appears to be rotated incorrectly and everything else appears to be correct, but it's this. So this triangle is forming exactly the same problem as this one. So if I go like R-I, D-I, R, D, R-I, D-I, R, D, you can see that it's done. It becomes solved. And that's after dealing with that particular kind of parity, or not parity, but false equivocation with that last layer. An equivalent to that would be if I were to go like, say, R-I, D-I, R, D, R-I, D-I, R, D. Let's rotate this out, and let's bring this in, and just rotate this around until everything else appears to be solved. R, D. Okay, so take a look at this apparent parity, this apparent situation. It would appear that just one is ruled out. This is the same situation as this over here. So the similarities here is that everything appears to be solved except one corner that's turned around, which appears to be a parity because that's impossible according to the law of cubes. I can't just have one corner that's turned around. The only way this can be turned around is if this is turned around. But if this is a symmetric shape, it won't appear to be turned around. So in this case, it's because this is rotated around that this appears to be the only one when it's also this one. Same thing with this puzzle. This appears to be rotated around only because this one is also rotated around. So to fix it, same way as fixing this. First rotate this back in. R-I, D-I, R, D, R-I, D-I, R, D. Keep going around until it's in, and then just bring any one of these triangles, red or green, doesn't matter, into here, and just keep rotating it around until it's solved. So too with this. If I run into a situation with this and this more complicated version of this, the dodecahedron version of this, I'm just going to rotate this down until this is correct. Then I'm going to swing this around until this symmetric edge, or corner here rather, is in line. Then I'm just going to rotate this around until this is in. So a more complicated shape, a dodecahedron shape, but still exactly the same kind of parities, exactly the same kind of pitfalls and pratfalls. So there you have it. The RLMinx, I guess, with a hexaminx, with the dodecahedron, which is the Megaminx. A nice completion of the series. And as you go down from puzzle to super puzzle to puzzle with potential false equivocations, it adds to the challenge and once again demonstrates Traiphum's brilliant work. Thanks for watching.